When we look at predicting unknown values with linear models, there are two types of predictions that we can consider. The first type is referred to as interpolation. That's where we estimate a value that's within a known set of data points These predictions are generally more reliable because we're working within some pattern that we've established with the data that's available. So we know that within this range of points, this linear association exists. So if we're predicting something within that range of data values, we're likely getting a better prediction. Then we also have what's referred to as extrapolation. This is where we estimate a value that's beyond the known data range. So for a data value that's larger or smaller than any value in our existing data set. And in these cases, reliability can decrease because any prediction that we make is based off the assumption that that linear trend continues. But we don't know that because we don't have any points beyond what our data set is to know that for sure. So we're kind of making some assumptions. And if you delve deeper into statistics, there are processes for knowing when a model is more reliable for extrapolation. But for our purposes, it's enough to know that we get better or more reliable predictions and potentially less reliable predictions depending on the values that we're plugging into our model. Let's see how this plays out in example 1, where we're given data on the number of yards rushed and touchdowns in a single season for 5 football players, 5 NFL players. I've already entered this data into Desmos. We can use the magnifying glass icon to zoom fit and see our data better, and then we can use that regression tool to get our linear model. So we have our linear model, which takes care of part A. We also have our correlation coefficient of 0.9395, which gives us our answer for part B and tells us we have a strong positive association, meaning this model is good for predictions. What we're going to do then is create a function, f of x. We could name it anything we want. We could also call it g of x, just some letter here. F of x is equal to this linear model that we created. And we'll see why we retyped that model with this function f of x notation in just a second. But first, let's go back and let's read part C. We want to predict a future or unknown value by choosing a practical value for n and then evaluating f of n. This means we can choose any value that we want that makes sense. In this case, choosing a negative number wouldn't make sense because we can't rush a negative number of yards. But we could choose a value like n equals 975. That value is not in our table above, but it is within those values. So this would be a case where we're looking at interpolation. So 975 is within the values in the table above for yards rushed, but we don't have this value specifically represented. Since we have this model typed in, this function typed in Desmos, now we can use function notation to quickly evaluate that by typing f of 975. Desmos will go ahead and spit out the value for that, evaluating that function at x equals 975. And if we round this, we get about 7.564. So what that tells us is that we would expect someone who rushed 975 yards to score approximately 8 touchdowns. Let's change that, not at least, would score approximately 8 touchdowns. That's not a value that we had in our table above. We don't have this as a known value, a known paired relationship. But the model suggests that based off the performance of those other players, this is what we'd expect. If we could find a player, or if a player in a future season rushed 975 yards, they would likely score 8 touchdowns. Again, since this was interpolation, that's likely to be more likely to be a reliable result, versus if we considered a case of extrapolation, where we consider a value that's outside of our data set, for instance, n equals 2,110, which is 5 more yards rushed than the current record holder as of right now. We would go back to Desmos and evaluate f of 2,110. And we would get about 15.58. So we could just go ahead and even round that to a whole number. So about 16. So we would expect someone who rushed 2,110 yards to score 16 touchdowns. But again, this is assuming that linear pattern holds, because if we look back at our table above, 2,110 is clearly larger than any value in our data set that we have for yards rushed. So we're talking about extrapolation. We're beyond sort of the known values that we've already thrown into our assessment here. So it doesn't mean that that prediction is wrong. It just means that it might be less reliable.